In the next exercise, 8.3, we're looking at a lot of conditional probability scenarios. So this stroke means probability of A given that B's already occurred. And that's equal to the probability of A and B divided by the probability of B. And with a little bit of mucking around, we can work out probability of A and B occurring is equal to probability of A times the probability of B given that A occurs. In the first question, number 1, you're shown a table of 100 people who have been surveyed asking whether they rode a bike and what drink they prefer, whether they like caffeine or a not caffeine drink. So a Carnot map or Carnot table or table as you've seen. Please note this summary table does not have the probabilities, but division there by 100 would get you there pretty quickly. So in 1A, you're asked the probability of not B and probability of not C. So a non-bike rider who doesn't drink caffeinated drinks. So if we look across there, that's 20 over the 100, 0.2 or 1/5. Now in the next instance, in B, you're told to find the probability of not B given not C. So we've got to work out the probability of not B and C given that not C has occurred. So the selection with that stipulation. We found that to be 1/5, dividing by 0.36. And on your calculator, now because I've got that in standard mode, you can see how I end up with 5/9 as my answer. Now in C, you're asked to calculate the probability of C given that B has occurred. So probability of C and B, so a bike rider who drinks a caffeinated drink. Now I'm just quickly putting that as 0.28, and given that they ride a bike, 0.64, and when I do that, 0.44, and when I do my division, that will come out to be 7/11. Now, I don't quite know why B's been asked at the end, but that's 44 and 100, and that cancels down to 11/25. Please don't forget that you are allowed to use your calculator in almost all parts of this unit. So it pays to let the calculator do some work for you if you wish. So 11/25 in that instance.